Hello, my name is Joshua Clay. I'm here because I wanted to share with you a hobby of mine and an interest of mine. I've been building little Nerf Dart robots like this. I guess it's an RC tank Nerf Dart thing because it's robot-ish. It's not like autonomous or anything, but I've been building stuff like this for quite a while. This particular version I put together, I built about a year ago. I wanted to make this YouTube video for quite a while, but I've been hesitant because it's one of those things where you want it to be perfect, so you keep putting it off. And I'm not the greatest public speaker or speaker in general, like I'm sure a lot of you. So I constantly question my ability and just put it off over and over and over again. But it's something that I'm very interested in and something that I would like to share with people, and hopefully there's others of you out there that are interested in it also. So here it is. I will talk to you about some of the features and some of the hardships that I encountered building this thing, and then we will shoot it and you can see the monster that I've created. So this particular thing here runs off of an Arduino Nano or Arduino RP2040, I think it is. It's one of the smaller Arduinos that has Bluetooth capability. I use the Bluetooth to interface with this PlayStation 4 controller. This is a controller. I chose the PlayStation 4 controller because you can buy them pretty cheap at a GameStop, for example. Very accessible, easy to find. The other things that I did to sort of make it more accessible and easier to find for somebody, or easier to build for somebody, was I built it on this Arduino Tank Tread platform. This particular Tank Tread platform is like $21, $22 on Amazon. I chose this platform because it has a metal base. I actually have one back here. This is essentially what it looks like. It comes with two motors. This is the hardware. It comes with two motors that go in each of these slots here, and then the tank treads slip on here, and the motor has like a toothed head like this, for example, that slides into the tank treads. So the whole point of this was to make it easier so that you didn't have to print every chain of the tank. I've seen a lot of videos out there of people who have designed their own tank treads, and it's really cool, but it is quite laborious. It's like its own little project. And eventually I would like to design one of these that uses 3D printed tank treads and accommodate that sort of thing. But again, for this one, I already had some goals in mind. My main goals primarily being to make it smaller, more compact, more of a tight platform. I wanted to make this as small as I felt like I could. I wanted to make the turret portion here very small and compact. I wanted to make this lower portion here that holds all the electronics. I wanted to make it tight and tiny. The front and the back come off. These top plates come off. Everything's connected with M2 screws. Nothing is glued together. It's kind of, I used a lot of woodworking techniques to design this, so everything sort of fits together like Legos. It's like an assembly heavy sort of thought process where each individual portion is an assembly where everything collapses in together, and where I need to fasten things, I use the hex head M2 screws for that. The front portion here, for example, slides out. I have an example. So this is the front portion. It has like the gate. This is, yeah, like the black gate. It sort of snaps in here. This one's broken because I dropped it. Well, this one's broken because this whole thing dropped from like this height onto cement. Long story. But snaps into here, snaps onto the front. There are trays for electronics. So there are trays like this where you have your mounting holes for your electronics, and they slide into the front here with all the electronics attached. For example, my buck converter for converting my 3-cell LiPo. I have a 3-cell LiPo here that powers it for converting the 12 plus volts down to 5 volts. So there's one 12-volt line that powers the motors for the flywheel assembly, and 5 volt comes through here, 12 volt to 5 volts. 5 volts powers the Arduino. The shooting mechanism, since I just mentioned that, is like a flywheel setup. Essentially, it takes a Nerf dart and squeezes it through these flywheels. These flywheels rev up, and it pulls this dart through here, shooting it very fast, a little insanely fast. I'll show you that in a minute. Another thing that I wanted to talk about real quick was the iterations that it takes to build something like this. It's easy to get discouraged when you're making something that's a new idea, something that you're passionate about, when you mess up a lot. And you can get dissuaded and you can put it down. Nowadays on the internet, you tend to see a lot of cool stuff that people were passionate about and they put a lot of time and effort into. You see the finished result, like you're seeing now. This is something that is very finished. I put a lot of time into making this. But what you don't see is all the iteration along the way, all of the things that went wrong, all of the things that made me say, dang it, maybe I should just stop trying. For example, when I first started making this, this was my component tray down here on the bottom. And like, this is the top here, which was not going to work. For example, if you look at the difference between the turret here, there's no back section here because I didn't realize that I needed a pusher mechanism, like something to push the dart into the flywheel cage that sort of projects it outwards. So I was planning this thing with knowledge that I didn't have. But that's the important thing about failing. When I was working at Stern Pinball under my boss, Chuck, he used to always say, fail fast, fail often. And what that has taught me is you need to roll up your sleeves, you need to get in there. You need to start doing the thing that you want to accomplish. And you need to fail at it in order to learn what you did wrong and what you did right. Because I feel like failing at something is the best teacher on how to proceed forward. So I literally have a big bin full of stuff like this, of scraps, of failures, things that did not work. But in the process, I learned a lot. I learned a ton about what I needed to do, about what needed to happen in order to make this thing a success. So I just wanted to share that because nowadays it just feels like you see all this awesome stuff online and it just feels like, man, these people, everybody is just so talented. So just remember, behind all that talent is somebody struggling and trying to make something work. And I am an artist in my real life. This mural behind me is something I painted. I work in pinball, like I said. I work for a company called Barrels of Fun. I am a 3D art director for the LCD screen. I plan and I make all the content for the LCD screen. Well, not all of it. I have some coworkers that help me for sure, but I do a lot for that. Anyways, I'm not a mechanical engineer. I don't regularly design electronics. I'm not a programmer, but I've taught myself C++. I've taught myself electronics with DC power supplies, and I've just winged it because I'm very interested in this stuff. So enough of me blabbing. Let's turn it on and I will show you how it works. So I'm plugging in the battery right now. So this is the battery right here, the LiPo battery. It is a 3-cell LiPo battery. So this is the on switch. And then I'm going to turn on my controller here. And once it pairs, as you can see, now it's paired. So now it drives. This stick here is for the pan tilt mechanism. This is a light. You need a light. Everyone needs a light. And then I'll show you it shoot. So it can accommodate several sizes of Nerf turret or Nerf magazines, I guess would maybe be the correct word. Excuse me. I've been sick lately, so I'm getting over that. So here is the turret. I'm going to shoot it at a shelf right over here off screen. It is loud. Oh, that wasn't the shooting part. It shoots hard. So, funny story, when I first built something like this, my main goal was to shoot a dart as hard and fast as I possibly could, which sounded good at the time. Nerf darts, yeah, you know, how bad could that hurt? Not that big of a deal. So I thought. I made one of these that was quite a bit larger, and actually it was one that looks like a shark. I can show you that at some point. I think it might be on my YouTube. And I programmed in a 3-round burst so that it would rev up, shoot, shoot, shoot. So I stood with my back to it. I had like an analog camera so I could aim with it, which I have a mod that I've made for this and some other improvements for the next version of this. And I stood across the room, I aimed it at my back, and I shot the 3-round burst. And when the very first dart hit me, it stung so bad. And it was through a sweatshirt. And it stung so bad, all I could think was, dear God, what have I done? And it left 3 welts, like good sized welts, like paintball gun kind of welts. Pretty wild. There are ways to tone it down. I do have some pretty vicious high-speed motors in here that really rev up the flywheel cage. So this is the flywheel cage. And the other thing is there's a thing called squish with these. So these motors are a little bit closer together. So that's why I can't push this dart. I can't push this dart through here. Like it'll bend the dart because there's so much squish right here that, okay, there it goes a little bit now. So see how it pushes that through? So these wheels get revved up super fast, and then I use this servo motor right back here that has like a pusher arm mechanism that I designed, and that's what makes it shoot. So it does its job. It shoots the things. Yeah. So if you'd like to see more about this, if you'd like me to make a more in-depth video, I have all the parts printed to make another one that's a little more updated. I fixed some things, I changed some things I didn't quite like. Not anything major really, but some tiny things for sure. But if you'd like to see more, if you'd like me to do a video where I assemble one of these, talk through my decisions about why I made things the way I made them, like, subscribe, comment. If I get enough people interested, then I will make more videos. I will subject myself to the camera, which is not my place of comfort. I will say that. But I appreciate you. I hope that you enjoy this hobby like I do, and I hope to see you again. Thank you.